Interval notation is used to write a subset of the real number set R using two values that bound it. But before we start talking about interval notation, let's remember these two symbols. This is greater than with the big number at the big opening and the small number at the point, such as 4 greater than 1. And the less than symbol with the small number at the point again and the big number at the opening, such as 1 is less than 4. Now let's look at some examples. The temperature T on a summer day fluctuates between a minimum of 20 degrees Celsius and a maximum of 35 degrees Celsius. As an inequality, we can write this as 20 less than or equal to T less than or equal to 35. As an interval, we can write this as T is an element of the closed interval 20 to 35. The square brackets are used when the inequality symbol contains or equal to. On a number line, we can represent this with a dot at 20, a dot at 35, and a line connecting these two dots. The dot is used when the inequality symbol contains the words or equal to. In this example, we have a watermelon that weighs more than 5 kilograms but less than 10 kilograms. As an inequality, we write this 5 less than W less than 10. As an interval, we write this as W is an element of the interval from 5 to 10. Notice that the round brackets are here used because the inequality symbol does not take the values at the end of the interval. On a number line, we have this with a circle at 5 and a circle at 10 connected by a line, horizontal line. The circle is used when the inequality symbol does not take that value. Consider two real numbers a and b, where a is less than b. So we have square brackets that go with the symbols less than or equal to and greater than or equal to, and the dot, and this is called a closed interval. The round brackets go with the symbols less than or greater than with a circle, and it's called an open interval. And now here are all possible options for writing an interval. First of all, open interval at both ends. How do we read this statement? The set, which is represented by the curly brackets, x values, the colon is read such that x is between a and b. And because we have round brackets, we have circles at both ends. A closed interval at the lower end and open interval at the upper end. So is the set of x values such that x is between a inclusive and b. b is exclusive. So we have a dot at a and a circle at b. Now, an open interval at the lower end and closed interval at the upper end. The set of x values such that x is between a exclusive and b inclusive. On the number line, we have a circle at a and a dot at b. Closed interval at both ends. So this is the set of x values such that x is between a inclusive and b inclusive. On the number line, we are going to have dots at both ends. Now, the next options involve infinity. So we have closed interval at the lower end and infinity at the upper end. So this is the set of x values such that x is at least a, or x is greater than or equal to a. So we have a dot at a. Remember that infinity is not a number, it is a concept, meaning unlimited, boundless, undefined. Therefore, there is always a round bracket at infinity and negative infinity. And on the number line, this is represented by an arrow, so it keeps going forever. Open interval at the lower end and infinity at the upper end. So we are going to have a circle at A and an arrow at infinity. Negative infinity at the lower end and closed interval at the upper end. This is the set of x values such that x is at most b. So we have a dot at b and the arrow keeps going to negative infinity. Negative infinity at the lower end and open interval at the upper end. The set of x values such that x is less than b. So this time we have the same, except we have a circle at b. Let's have a look at a couple of examples again. Use a number line to represent the sets given below. The first example represents the intersection between the interval -2 to 7 and 0 to 10. Notice that we have a square bracket at -2, therefore we need to have a dot at -2. Similarly, there is a square bracket at 7, so we are going to have a dot at 7. So this is the first interval from -2 to 7. The second interval starts at 0 with a round bracket, so we have a circle. It ends at 10 with another round bracket, which is again a circle. Because we are looking for the intersection between these two intervals, remember that the intersection is where the two intervals overlap. The final interval is going to be from 0, open circle, and 7, dot or closed interval. The second example is the union from negative infinity to 1, where 1 is a square bracket, with the interval 3 to 11. So negative infinity has a round bracket and 1 has a dot because it's a square bracket. The next interval starts at 3 with a dot because there is a square bracket and ends at 11, which is a round bracket, so we are going to have a circle. So this union is represented by these two horizontal lines on the number line.